Now let us find the derivative of cosine function using first principle. That means that the derivative by definition is limit h approaches 0 for f of x plus h minus f of x over h, right? So that difference quotient formula. Okay, so we need to find derivative of cosine x. That means limit h approaches 0 cos of x plus h minus cos of x over h. Now here we can now apply the difference for trigonometric ratios. So we know a formula which is cos of c minus cos of d, which is equals to negative 2 times sine of c minus d by 2 times sine of c plus d by 2, correct? So that's the formula which we are going to apply. I'll provide you a link which gives you proof of these formulas, right? Okay, so we get limit h approaches 0 minus 2 sine of c plus d means c minus 2, let me do that first, which is x plus h minus x over 2, correct? Times sine of c minus d, which is x plus h minus x over 2, correct? Divided by h. So that gives you a limit h approaches 0 minus 2. Well, I can bring this minus 2 here, right? So, okay, let me do it in the next step. So we have sine of x is 0, so we get h over 2 here. And this side we get sine of, did I do both minus? I have to plus this one, correct. So we get 2x plus h, so we get x plus h by 2 in this case, right? Over h. So that is what we get after applying this formula. Now we can rearrange, right? So if I rearrange, I get limit h approaches 0. Now I'll bring this 2 down, so we get minus sine of h by 2 over h by 2, correct? This is with the negative sign, times sine of x plus h by 2. Perfect. Now this limit is 1, so I could write this as minus limit h approaches 0 sine h by 2 over h by 2 times limit h approaches 0 for sine of x plus h by 2, correct? So the limit of the first part is 1, as you know, so we have minus here, and here if I substitute 0, I get sine x. So we have shown that the derivative of cosine x is negative sine x. So that is how you could easily find, using first principle, the derivative of these basic primary trigonometric ratios. Thanks for watching and all the best.